Everyone. Today we are going to discuss about binary search. Before discussing about binary search, what exactly this binary search word says, let's try to understand. Search means we are trying to find something. So we are trying to find something by using the technique called as binary. That means we divide an array into two equal halves, two halves, and we will be searching one half of it, not the second half. So it is much efficient than the linear search algorithm which we have discussed in our previous session. So now we will be concentrating more on binary search. For understanding this binary search, I'll be taking an array which will be consisting of some elements. So I'll be taking some elements like this 10, 20, 30, 40, 50, 60, 70, and I'll take 80 as well. So now you can understand this. So I'll be naming this array as A, and all the elements present in this array are sorted. So what do we mean by sorted? Either they should be in the ascending order or they should be in the descending order. So now I'm taking the elements in the ascending order. And if the array is sorted only, I can apply the technique called as binary search. Otherwise, it is not possible. And I'll be giving the index number for this particular array. The element to be searched, I'll be taking it as the element to be searched is 20. I need to search for 20, or I'll be taking it as 30. I need to search for 30. Any element can be searched. So I'm taking for the element called as 30. Now, how this binary search algorithm works, let's try to understand. So the first and foremost thing is this is called as the leftmost index, and this is called as the rightmost index. I'll be naming this as leftmost index, and this is the rightmost index. Now, what we have to do, we need to identify the middle element. So, how do we identify the middle element? Middle element is nothing but the leftmost element, leftmost index plus rightmost index divided by 2. So, that will be the middle index. So, first, how do we identify the middle index? Let's calculate that. So, mid will be equal to your leftmost index. Leftmost index is 0 plus the rightmost index is 7 divided by 2. If I make it as that, 3.5 something will get, but approximately it is rounded up to 3. So that means, so I'll be getting the answer as 3. Fractional part is ignored since it is an integer division. So I'll be getting the index as 3. This will become a mid element. So once it becomes the mid element, I need to compare my key element is equal to mid element or not. The mid index is 3, mid element is 40. I'll compare 30 is equal to 40. If 30 is equal to 40, if 30 is equal to 40, then what I'll do? So that means I'll stop my comparison here. I'll stop my comparison here and I'll say that this is the element and I'll return this particular index called as 3. But that is not happening here because 30 is not equal to 40. That means when 30 is not equal to 40, then I should make a next comparison. The first comparison what I need to make is, so I need to check whether my key element is equal to the in array's mid element or not. If this is equal, then I need to return the mid index. Or else I need to check whether this key element, since my array is sorted, I need to check whether this array is less than this mid element, the key element is less than the mid element, or it is greater than the mid element. So the next comparison which I'll be making is, if the key element is less than a mid element, then my comparison should not be made in this particular part of the array. Please try to understand this. The comparison should be made in this particular part of the array. So I'll be making the comparison with this particular part of the array. So I don't want to compare another part of the array. So that means if I compare here, that is enough. I don't want to compare here. So that is what the concept of binary search is. You need not search this particular part. It saves your time. So you can search only this particular part. Then how do we do if this case is true? If this case is true, then I'll be replacing my right index with mid minus 1 index. So what is my mid value? Mid value is 3. 3 minus 1 is 2. So this becomes my rightmost index now. This becomes my rightmost index. Again, this procedure should continue until I found an element or this left value and right value gets interchanged. Until that, I should be keep on continuing this operation, and I'll be showing you the program. So as of now, let's try to understand the concept. Now I need to again calculate the middle element. So how do we calculate the middle element? It is, so leftmost index is 0 plus rightmost index is 2 divided by 1. So if I do this, so I'll be getting the index as 1. So this will become my mid element. This is my mid element. So now again I'll compare whether key value is equal to the mid element or not. So key value is not equal to the mid element as of now. So that means this comparison is false. Then I need to check whether key value is less than a of mid. No, key value is 30, a of mid value is 20. That is also not true. So that means the next comparison, what I need to do is whether key value is greater than your mid element or not. If it is greater than the mid element, then what I need to do? I need to replace my lower index with, just a second. I need to replace my lower index with, so I need to replace lower index with middle value plus 1. So this is what the index it says. So that means I need to replace my leftmost index. So lower index in the sense it is leftmost index. I need to replace the leftmost index with mid value plus 1. So left mid value is 1, 1 plus 1 becomes 2. So left index also starts pointing here. So when both are equal also, we need to continue this operation. Left is equal to right also, we need to continue this operation. So when the leftmost index is less than or, leftmost index is greater than rightmost index, we need to stop this operation. Otherwise, we need to keep on continuing. So now my leftmost index is also 2 and rightmost index is also 2. Let's calculate the middle value. How do we calculate the middle value? It is 2 plus 2. 2 plus 2 divided by 2. So the answer is 2 only. So mid element also starts pointing here now. So mid element also remains here only. So the middle index is also 2. Now I need to compare the key value is equal to the middle element. As key value is 30 and middle element value is also 30. So both are equal. Then I'll be returning the middle index plus 1. So what is my middle index? 2. So 2 plus 1, that becomes my index. That is, it is a third element present in my array. Or else you can say it is present at the index number 2. Both are true. This is how your binary search algorithm works. This is how your binary search algorithm is going to work. So I did not search the entire array. You can understand only half of the array we have searched here initially. And again, what I made is, so after this, we calculated the middle element. We got to know that it is in this particular part. So we checked only this particular part of the array. This is how searching reduces your time compared to the linear search, and it is an efficient algorithm compared to your linear search when the array is sorted. Now let's understand the programming part of it. How do we write this program? Now let's try to write this non-recursive program which I have written was the concept of which I have explained was concept of binary search. Now I'm solving this binary search by using the non-recursive approach. Write a C program that use non-recursive functions to perform the binary search operations for key value in a given list of integers. So that means this is what they have given, and input format also they have given. So they'll give the size of an array and they'll give elements of an array and the element to be searched. And we need to say that the index which is found or not found. If it is found, we need to say where it is found. And if it is not found, we need to say it is not found. So you can see the test case here, the size they are giving and the elements, three elements they are giving, and search element is they are specifying 6. So 6 is present at the second index, we have to say. So array index starts with 0, but we need to say at which position it is present. It is present at the position number 2. So let's start writing a program. So I'll be writing my program. I'll start with the main function. Inside the main function, first I'll start taking this particular size. To take the size variable, I'll be taking the variable called as n, and I'll ask user to enter that particular size. The same way how they have given in the question, in the similar way we are doing it. So now we need to accept this size. So for that, I'll be using my input function called as scanf. And since it is an integer variable, I'm giving the format specifier as percentage %d. And then I need to read the elements. For that, I need to declare an array first. So I'm declaring my array as A, and I'm giving the size as n, since n elements to be stored. I'll ask the user to enter the elements. Since n number of elements are there, we need to loop across to store all these elements or to read all these elements one by one. So I'll be initializing array index to 0. Now I'm moving across all the elements. I'll increment step by step. Now I'll be reading all these elements. I'll be reading all these elements and storing into my array. So how do we store it into the array? So I'll just specify the index of the array. Now, after reading all these elements, what this is, search element we need to read. So let's read that search element also. I'll ask the user to enter the search element. So this is according to the input function what they have asked. I'm doing accordingly. According to the program what they have asked, accordingly we are doing. So now we need to read that search elements. So for that, again, I'll use scanf, but search element I did not define. I did not declare. So I'll be declaring it as key now. So I'll ask user to enter that search element. So it is percentage %d again. And I'll be reading that key element now. After reading the key element, now what I'll do, so we got the key element and we got the array and we got the number of elements present in the array. What I need to do now, I need to perform the operations of binary search, which I have discussed previously. So before writing the binary search program here, so the code here, what I'll do, I'll make it as a separate function and I'll call that particular function. So I'll be writing it as binary underscore search as my function, binary underscore search as my function. And for this function, I'll be passing, I can say array as a parameter. And again, I'll pass number of elements in that array, or else I'll pass the zeroth low, I can say the first index, that is leftmost index. And the rightmost index will be size minus one. That also I'm passing it as a parameter. You can understand here, I'm passing A and I'm passing the leftmost index and I'm passing the rightmost index. Rightmost index, since array index starts with 0, it ends at the size n minus 1, that is size minus 1. So that's why I'm passing n minus 1. And again, I'm passing the key value to be searched as a parameter to the binary search algorithm. Sorry, binary search function. Now I'll define the binary search function before the main function, or else you can do it after the main function and declare a function here or write the function prototyping. So I'll be doing it before only. So I'll just write it as a data type as int, since I'll be returning some value from here and I'll be printing that value in the main function. So I'll be writing the data type as int because index I'll be returning. And my function name I have declared it as binary underscore. So I have called it as binary underscore search. And since the first element being passed in the formal parameter or in the actual parameter is array, so I need to have an array to hold it, and I'll be giving the size of an array as 100. No restrictions on that. And again, I'll be giving my the next element as the leftmost index. I'll be declaring it as leftmost index. The next element is the rightmost index. I'll be giving it as right. And the next element is key itself. So I'll be giving it as key element only. Now inside the function definition, so we have to perform this operation. First, I'll use the while loop until where we have to iterate these operations. I have discussed previously until your left value at the leftmost index is less than or equal to your rightmost index. You should keep on performing this particular operation of searching. So until this particular operation is true, we need to be keep on performing the operation of searching. This is what we have discussed in our previous discussion. So when the leftmost element is less than or equal to the rightmost index, or the leftmost index is less than or equal to the rightmost index, we should keep on performing this operation. Or else when the element is found, then we need to stop this operation. Or else when the leftmost index crosses your rightmost index, then you have to perform this operation. So that's how this loop has been written. And now inside this, as we have discussed, we need to declare a mid element and we need to calculate the mid element. So how do we calculate the mid element? I have already discussed. It is left plus right divided by 2. This is what I have discussed. This is the leftmost, sorry, this is the mid element. Once after calculation of the mid element, then what we have to do, we need to compare. The first comparison which I told was, I need to check whether the middle element is equal to my key value or not. If the middle element is equal to the key value, then I need to return. Since I have written a function as an integer type, I can return an integer value. So I will return middle value plus one index because I need a position and I don't want I can say the index of an array. I want the position where it is present. So I'll be returning mid plus one. So I say it as return mid plus one. Then after this, I'll be writing one more condition. If this is not true, I'll be writing another condition. See, the first condition is I'll check whether it is equal or not. If it is not equal, I need to check whether key value is less than a mid value or key value is greater than a mid value or not. So I'll just make that comparison now. If key value is less than a middle element, that means I need to search in the left half of the array. So for that, what I'll do, I'll replace my rightmost index with, this is what we have discussed. I'll replace my rightmost index with, I can say mid minus one. This is what we have discussed in our explanation. If this condition is also not true, then I'll put on one more else if condition, or you can write it in the else condition also. That is also true. If key value is greater than a of mid element, so I can say that means you have to search in the right half of the array. So to search the right half of the array, your left index has to be replaced. So I'll be writing it as mid plus one. So I will be writing it as mid plus one. And this operation should continue if the element is not found after the completion of the complete while loop. So if the element is not found, I'll be returning minus one. So minus one indicates that the element is not found. So this is what your binary search algorithm, whatever the concept I have explained there, accordingly I have written this particular algorithm here or code here. So now since the binary search algorithm is returning something, I need to have a variable to hold its result wherever the function is called. So I'll just declare one more variable called as a result, and I'll assign the result of binary search call to that particular variable called as result. Now I'll check if my result variable is equal to minus 1, then I say that element is not found. So what we have to print here, let's see, not found we have to print. So you can observe in the test case 2, it is saying that not found. So I'll just write my printf function and I'll say it is not found. So I'll use a new line character. Is it needed? It's not needed. So I'll not use the new line character. Else, if this is not true, that means element will be found at a particular index. So I'll just print that element's position. I can say it is found at percentage %d. I'll say that index is stored into the variable called as result. So I'll just print that result variable. That's it. Our program is completed. See, binary search result returns the result. Either it is minus one or the index of the element which is found, and it will be stored to the variable called as result. And I'm comparing if the result is equal to minus one. If it is equal to minus one, and I'll say that the not found, or else we print that particular index where it is found. Let us execute and see now. Let us execute and see now. So it is asking for the size. So I'll give the size as the same example I'll take. I'll give the size as 8. So that means 8 elements will be there. So it is asking for the input elements. I'll give 10 space 20 space 30, 40, 50, 60, 70, and 80. So now it is asking for the key element. So key element, I'll be, as discussed in the previous example, I'll be giving 30. See, it is saying that element 30 is found at the index number 3. Sorry, not index number 3. It is at the third position. Index number is 2, but the position is 3. Okay, this is how the program works. Let's submit and see this. Let's submit and see. So there is an issue with the network. I'll just refresh it again. Submit and see. If we submit, should submit successfully. It was an internet issue before. So it is submitting for all the test cases. This is what the program for binary search is.